Mr. Hudson. I almost had it all fixed. All right, let's talk because I'm recording now and we should be relatively ready to go. 512. You can see went from Monday and kept going with Tuesday, and it's probably going to keep going today because one of the worksheets you just picked up is a 512 worksheet. So please keep out the worksheet that says 5.1.2 resource page at the top. Right up here says 5.1.2 resource page. And then I want you to pay attention to the fact, actually go ahead and put your name on this right now. Put your name on this worksheet. I'll do the same thing. There's a really important reason. Because I can bet at least one of these will get left in my room today. Either from your class or the next class or somebody. Gravity. Flip it over and look at the back. This is also your resource page for 5.2.5, which we'll definitely not get to until next week. I'm trying to be green, right, or like conserve paper. There's no reason to not copy things using both sides of paper, because we're just going to use this resource page today, and then you can use it like when you're doing homework, or maybe like when we have a mastery, cough, cough, wink, wink, hint, hint, like on Friday. So, this is going to become important, and then also we need it next week when we start learning about probability trees. So, you should have that in front of you. You should also have the Chapter 4 follow-up in front of you. Notice, it says even if you've corrected the Chapter 4 mastery, which if you haven't, you need to. Those are in map now. Like I promised, well I didn't promise, but like I said yesterday, I didn't get them until this morning, but they're in now. So if you still have the Chapter 4 Holiday Cheer Celebration of Learning, and it's not an M yet, you need to turn it back into me. And you might need to come to math lunch or whatever else. You'll notice these problems are similar to the problems you had. Instead of tulips, now we're talking about roses. So it should all feel very similar to what was on the original. And you notice number 7 starts to make us start thinking about percentages, right? Because now we're getting into more percent work. And then you should have 5.2.1, which I do not want turned in today. I do not want turned in today. We will, before you walk out of class, fill in our standard deck information for a deck of cards. Guys, my grandma thought any game involving cards was like evil or like anti-religious, and she was very religious. So like when I started playing any games, my mom was like, hey, don't tell your grandma, which was like a weird thing that we were keeping something from grandma. But like if I had asked her how many cards are in a deck, she'd be like, I don't know, that's evil. Like I don't use cards. So it's okay if you don't know what's in a deck of cards. It all depends on your family, but you need to know, right? We're going to start to use it to develop our probability thinking. And a dice, whatever you want to say, it just doesn't have enough for us to think about. A deck of cards has a bit more variety, right? So a dice, we all know about dice, but we'll talk about deck of cards. John? Not yet, because we're about to check those answers. So some of you on 511 turned in answers that we talked about being wrong. So guys, I really want to be critical here. Like, I'm not going to count your homework wrong, but I might start to make people come see me if you turn something in with an obvious wrong answer. Because you don't know what you're doing is what that says to me. What it normally actually means was you were rushing, or you copied, or you did it on the bus, and your brain wasn't actually turned on, or something else. But what it says to me, I'll pick on John since he's always raising his hand. If John turns in a problem where we're adding fractions, and he doesn't do common denominators, and he treats it like multiplication, I think John doesn't know how to add fractions. So I tell John he needs to come see me. And then he was like, oh yeah, I was just being lazy. And it's a waste of time. So if you don't have one of these answers, it's your job to ask me, wait, why is that the answer? Yeah, thank you very much, Eve. Can you not read your own handwriting, or what do you mean you think you guys? Okay. Sometimes you guys can't read your own handwriting. It's funny. Oh, and we need to talk about 22 also, because Layla Graff was supposed to tell us. All right, I forget who I told to remind us, but yeah, we need to talk about the scale factor problem too. That button. You said 19. In 19, it says Janelle earned 90% on a test and got 63 points. So there are different ways we could solve this. We could set up one of our models and kind of show that Janelle got 90%, which is most of the test. And that would be 63 points. We could then split this up into tens and figure out what every 10% is worth. So guys, for 90%, how many 10%, like yesterday we were doing that 10% rule, the Meineke method, right? How many 10% are in 90%? 9 of them. Or guys, remember what we did yesterday, we can set up like points over percent. And if I want to get to 10%, how do I go from 90 to 10? Divide by 9. So do the same thing on top. What's 63 divided by 9? 7. How do we go from 10% to 100% times 10? So how many points total? 70. So actually, even if I try to set up the model, like the number line or percent bar, whatever we want to call this. I don't know why I'm at a loss for words. We still need to use our proportional thinking. Guys, this should be becoming like a habit where we just set up fraction equal to fraction. One of the best ways that we can solve problems with 2 different units, right? Percent versus points. I know we need to talk about 22, so are there any other questions on 20 or 21 or 18? I know we need to talk about 22. I also changed 22, so please don't pay attention to the answers they have. This is wrong. These are correct. These are correct, but this A is wrong because I turned the question around, I believe, from A to B. Yeah. Farah. 18. Absolutely. 5 parts red, 15 parts yellow. So how many total parts are there here? If it's just red and yellow. 5 plus 15? 20. There are 20 parts in total. And guys, one of the reasons we use parts instead of something else is like, depending on what country you're in, will depend on what they measure in, right? Cups or quarts or milliliters or liters or gallons, like different countries, we measure in different stuff. So what percent of the paint is red? I know you asked about B, but we might as well talk about A first. So I set up my red paint over my total, remember part divided by whole, or part divided by total. I could do that division, or I could just think proportionally. We want to get to over 100. How do I turn 20 into a 100? Times 5, so we do the same on top. And we get 25, so it is 25% red. Then the simplified ratio of yellow to red. Guys, one way to write this is verbally. If you didn't do 18b yet, I would write yellow colon red. Then we fill in what the yellow had. So how many parts were yellow? Wake up, I'm going to start using random cards. How many parts are yellow? 15. How many parts are red? 5. So then the simplified, though, means these numbers get along. What can both of these numbers divide by? 5. So if I do division by 5, it's really that the yellow is 3 times as much as my red. For every 1 part of red I have 3 parts yellow. Because the other way I could have written all this is yellow over red. So 15 over 5, or 3 over 1. We can write ratios. And we have this at the top of 511, I believe. And some of you chose not to write it down, because as I was checking homeworks, I saw that. So we talked about a ratio can be set up with colon notation, but that essentially tells us to divide, right? So when we built this, we showed 3 colon 15, but that essentially showed us to divide. So if we come back over here, same thing. This is really 15 divided by 5, which is really 3, right, if we do that division. Other questions aside from 22, because I'm going to do 22 for sure. 21 comes back to common denominators. So B is harder than A. A we can double, right, to get our denominator to what we want, so we only have to mess with that fraction. Let's look at B then. I always improper first, because mixed numbers are just tricky to work with. So to improper here, 2 times 8, 2 times 8, 16 plus 5 more, yeah, you're just a step ahead, is 21 over 8. Minus 1 times 3, 3, and, and then add 1, John. I was going to let you say your 4 and be right this time. So minus 4 over 3. We can't do this because we don't have common denominators. So, what's a common denominator 8 and 3 can both get to? 24. So I'm going to have to do times 3 over here, times 8 over 8 over here. And I'm not going to finish this workout for you. If you need more help with this, please come see me at math lunch. Like, we need to do those multiplications and then do those subtractions. I will show you the answer again. So the final answer you should get to when we reduce it, or when we take it to mixed form, is 1 7/24. But if you leave it improper, is that what you're trying to say, John? What is it if you leave it improper? 31 over 24. So if you left it improper, it'd be 31 over 24. Now, I changed number 22, which I should alert you guys when I change these, because if you go to try to use homework help, you might be confused. So my bad if anyone tried to use homework help. We're going to go from A and get to shape B. So we're going this direction. Are we getting bigger or smaller? Bigger. So our scale factor needs to be bigger than 1, because we get bigger. To find our scale factor, just take a length and compare it to a length, but they have to be matching sides. 18, I can't match up. 15, I can't match up. But 50 and 30, I can match up. So remember, scale factor is new over old. You guys, you might want to write this down. Even if you already did the problem, you might want to write down scale is new over old. They're telling us B is our new one. So it's 50 over 30. Or that could reduce to 5/3. If you try to put that in a calculator, you're going to get a gross decimal number of 1.6 repeating. I would not use that. I would just use the fraction 5/3. Because we took the 50 as our new, the 30 as our old. So when we go from A to B, we multiply by that scale factor 5/3. But if we're getting smaller and going from B to A, what do I do with the scale factor that I had going the other way? Either we can divide by that number, or if you still want to multiply, flip it over. Guys, it's like doing times 2 or times 1/2 times 3 times 1/3, right? Times 4 times 1/4. You just flip it. You take the fraction or the number, flip it over. If you need more help with this, please come see me. I'm happy to help you think through this. but I did this on purpose because this is a nice decimal. It's actually 0.6 if you find that decimal. I wanted you guys to see this and realize, oh, the fraction here is better, right? This fraction is better than that decimal. For 3/5, it doesn't really matter if you use fraction or decimal. All right, if you need more help, please come to Math Lunch or AO or Extensions. We do have lots of opportunity to get help, but right now I got to keep going with class. So here are announcements. Right? If your 512 is done, you can turn that in, but it's not due till tomorrow because we're still working on the lesson. So if you look up here, 512, oh, I guess I left it on today. So you can turn it in today if you want, but I should bump this. If it's not done, that's fine. If 512 is not done, keep working on it. Today we're going to do this handout. We're going to use random cards to work through some of this. Then we're going to jump into 521, talk about like a deck of cards and probability. Friday, not tomorrow because tomorrow's Thursday. Friday, we will have a percent mini mastery very similar to what we're about to do. Hint, hint, cough, cough, nudge, nudge. Wink, wink. Side jab, side jab. All right, so pull this out. You guys were doing a really good job yesterday talking with each other. So as I walk around the room, I should not see you working on your homework paper. I should not see you working on your homework paper. I should see you with this worksheet out, talking with your teammates, trying to fill in as much as you can. So start with A, because we're all going to start at the top. So here's a reminder of what we did yesterday. I guess let's do A together. Let's go ahead and do A together. Then I'll probably flip my 5-minute timer to make sure you guys have some time to work. I am still going to use random cards, though. Aiden, how many sections is this likely broken up into? I mean, we can count, but what do you bet it is? It's probably broken up in tens, right? Because that's a nice number. If we count to double check, these are all tens. Percents always go on bottom. So what percent would go right here in the little section on the right part of our bar? If it's two, ooh, yeah, Eve's got it. If it's 2 sections, right, from here to here, this would be 20%. Sorry, well, thank you. Sorry, masks, it's hard to hear. What percent goes over here under the 8 sections? 80, right? Because if it's broken up into 10 sections, every section is 10%. So what you want to fill in up here relates to these statements over here on the right. Check it. Read these. 20% of 30 is, well, that's the number that we're going to fill in up here. Right? This will be our 20% of 30. Guys, what's 10% of 30? $3. Use that. Use the 10% rule. So you might want to make a reminder up here that the 10% rule is really helpful. Or 10% method, or whatever we want to call it. 10% trick. I don't like the word trick, but it seems like it's kind of like a, woo, like all of a sudden you can solve things. So if 10, ooh, they ask us that. 10% of 30 is, so we can go ahead and fill this in. 10% of 30 is 3. Which means, Layla Davis, what's 20% of 30 then? 6. So go ahead and keep going. I'm going to flip the 5-minute timer. I'll walk around and take questions if you want, but I'd rather you ask each other whatever questions you got. You don't really need to be able to see the order of these right now. They're already talking to people. So we're going to do this for like 5 minutes. All right, I realize we should do one more thing together, so I'm going to lay my timer down for a second. We'll pause time. Right? Kind of weird to stop time. Guys, right here, I would like you to write some work out here to remind you of what we can do with that. Is the 30 a part or the total here? It's the total. So when they ask us to figure out a percent, guys, look up at the dry erase board. In the middle, written in green, percent is part divided by whole. And then we can do times 100 or just move that decimal. So what we can do here, and you could have figured this out from your model over here, because we're going to end up with 24 right here. I heard some people saying just subtract. But we can do part divided by whole. That gets us 0.80, and then we move the decimal 2 places. This is our multiplication by 100. That is how we get our 80%. Part divided by whole, then times 100, which moves our decimal place. So A is totally done for you guys. Go ahead and keep rolling on B, C, D. If one totally has you stumped, raise a hand. You got 2 teachers in here that can come around and help you. So on that second one, you probably want to start by thinking how many sections. Never enough time. So how many sections are we broken up into? Ooh, total of 4. 1, 2, 3, 4. So what's 100% divided by 4? That'll be each section. Right? So each section. You might want to calculate, right? None of you guys got a calculator, right? Guys, you can still totally use calculators here. It's in 4 sections. So they both got something written that you don't. So does it make sense how we can find the percents again when we want to talk through that? Why are we dividing by 4? So you can help. We're trying to bump on the logs there to you guys are listening. We're trying to help you. So 100% divided by 4 sections. Grab your calculator, 100 divided by 4. That means each of these is 25. So we can go ahead and fill in 25% in there. And then how much percent is over here? Well, that's 3 of those. So what's 25 times 3? And we got to fill in the numbers on top. I'm going to pause you again real quick and then give you more time. Carmen, can you tell me what you guys did first on B? And there's different ways to do this. Yeah, always. Kylie, do you want to tell me what you guys did first on B?
For B, the first thing we did was figure out what how much was each of the little dots.
Yeah, so there are 4 sections here, right? So you can kind of call it sections or regions or whatever you want to say. So if there are 4 of these for 100%, what is each of them?
6.
Ooh, you're telling me the stuff on top.
Oh.
You're right. You're right. This is 6. But we need to come back to how we find that.
I'm taking over here. 18 divided by 3 is 6.
That. So check it. This 18 is 3 of the sections. 1, 2, 3. So if we divide by 3, 18 divided by 3 is 6. So each of these, like 6, 12, 18, each of those is 6. Makes sense, because 6, 12, 18, then 6 more. What do we have total? What is 18 plus another 6? 24. Vincent, when we go to figure out the percents down here, can you talk to me about that?
Yeah, so what I did was I figured out that 75%, since there are 4, then if you times that 4 by 25,
Ah,
100.
the other way to think through this, right, is like 100 divided by 4. Tells me what each section is. So this out here is 25%. Make sure you got your percent signs there. This right here, Vincent said, is 75%. And then I can fill these in over here. 75%, because that's the 18, right? Of what? What was our total? 24. So 75% of 24 is 18. Ooh, 50%. They didn't even, we don't even really see that over here, but what's 50% of? Ooh, yes. Sorry, my brain is, I'm debating how it actually is working us through this. Because really, this is supposed to split right there. So 50% is interesting. Would be 12. So then I believe what they're trying to get us to, kind of like the Meineke method, but instead of dropping to 10%, they're cutting in half. Then they're going to cut in half again. So 25% is half of 50%, right? So 25%, we found out, is actually $6. Careful. How many sections is this line broken up into? 5. There are 5 sections here. So be careful. Go ahead and keep working. I don't know which. No, it doesn't really matter. I dropped time, guys. How'd you figure out this? Okay. So that's still going to be percentage, though. So if you did 60% divided by 3, your answer is percent. What we need to figure out for up here is what number of 24 is 60% of 24. So like what we're writing out here, we're probably solving 40% of 24 and 60% of 24. Now we could start by saying what is 20% of 24? What if we start at 10%? What's 10% of 24? What if we divide that by 10? To find 10% of something, we divide by 10. So what is 24 divided by 10? That is 10%. How could we use that to find 20%? Yeah, to go from 10% to 20%, we can just double. So if we double that, we'll find what 20% is. So we're running out of time. You're good. You're all like, I did not expect us to finish this. Keep this paper. We will keep coming back to it when we have time. Hey, whoa. Did I say put things away? Did I say get out of bind? No. Quit making assumptions. Let's talk about this. So in C, Jesus, the first thing we said we were going to do is take our 100% and divide by 5, because there are 5 sections here. What's 100 divided by 5? 20. So each section, and guys, a few of you, as I walked around, each section is 20%. Meaning, Mia, what percent goes down here? 60%, because it is 3 of those sections. Which means, not here, Isabella, what percent goes over here? 40%, because we have 2 of those 20% sections. Questions on finding the 60% or the 40%? We took our 100, broke it up, now we're multiplying it back together. So now, Farah, if we wanted to start by using maybe like the Meineke method and we wanted to find like 10%, I'm actually going to go and write that here. These guys, I'm never going to collect and check this paper. Like, we're using it so you have a resource page. Hint, hint, cough, cough. If you have an open notes test, this would be a really good resource. Farah, what's 10% of 24? We just calculated this together, right, on your calculator? What was that 10% of 24? Farah, are you with me? Ooh, you're close. 2.4. I think you probably tried to type that in too quickly. So if 10% is 2.4, because if I take 24 and I divide by 10, right, we get 2.4. What about like 20%? How do I go from 10% to 20%? Times 2. So do times 2. 4.8. Oh, but it's money, so I should probably do 480. How could I go from 20% to, I don't know, 60%? How do I go, or from 10% to 60%? Either way, we just multiply. So we either can multiply by 6 or multiply by 3, or there's actually some other options. But what do we get here? 14.40. look up here again. You can. What is always an option is grabbing your calculator and doing the math in the calculator. 40% of 24, right? For my last section right here, that is 40% of 24. My calculator will tell me that's 9.6, and that is what it is. Like, I can find this a few different ways. We can always go back and use our calculator. We're not done with this worksheet, so please definitely keep track of it. But I need to help you fill in some information on 5.2.1. So go ahead and get out 5.2.1. All right, so pick a card, any card. What is the probability of picking the following cards from the deck? So you guys know that for your class, this is your class, right? I'm not going to put them face up because your guys' names are on there. And I do this because at the heart of 7th grade math is probability. And you guys can probably figure out if this is your card and this is the whole class and we're at the beginning of class, your chance of being picked is 1 out of whatever's here. But when we get into a deck of cards, there's a lot of details to be talked about. So check it. I had some people help me this morning. One way to sort a deck of cards is numerically. 2s, 3s, 4s, 5s, 6s, 7. We go by number. How many of each number are in the deck of cards? 4. There are 4 2s, 4 3s, 4 4s. There are no 1s. However, a lot of people will say that aces can play as 1s. Actually, in some games, they're worth like 1 or 11. Because they'll say face cards are worth 10. And then aces will play as a 1 or an 11. In your book, when it asks you a face card question, if it doesn't tell you whether to count ace as a face card or not, you can decide, but a lot of times it'll say like whether aces count as face cards. I think of them as powerful cards like face cards, right? If somebody asked me, I think of aces as being the highest card, not being a 1. But there's another way to split up a deck of cards. Anyone know the other way that we can think about the differences in a deck of cards? Vincent or John, don't care. Color, and specifically then, each color, so we've got red and black. We're going to take out these extra cards that don't matter. Guys, jokers do not count. Okay, we always take out these extra cards unless the game we're playing tells us to use them. So, alright, so I've split by color, red and black. But what do we notice about the red cards? There are different symbols. So, in red cards, there are diamonds and there are hearts. In our black cards, there are, and actually guys, some of us don't know how to call these correctly. This symbol is a club. A lot of people like to call it a clover, but that's a club. And this one makes sense. Guys, it's a shovel. It's called a spade, but it looks like a shovel. This would be the handle, and that's the part you dig with. Actually, I guess I can show you this. So this is like the part of the shovel you dig with, and this is the handle. It's a spade. A spade is another name for a shovel. So these are spades. These are clubs. And if remembering clover helps you remember clubs, CL, right? Clubs and clovers. So let's, on our homework, write this stuff down. The first thing we probably care about is how many cards total are there, Anyone ever had a really mean sibling where they're like, hey, you want to play a game? It's called 52 card pickup. And they like fly all the cards all over the room. I'm not going to do it because then I have to pick them up. But there are 52 total cards. Not counting jokers. Right, but don't, like, let's not confuse ourselves because all the math we're going to do is going to involve 52 total.
I'm sorry for the interruption, Phoenix. I need to see Colton Kane and Victor Miller in the office for just a moment. Colton and Victor. Thank you.
So this splits down to half of the deck, or 26 cards are red, 26 cards are black. But that splits even further. And guys, I'm going to go up here. Red was split up into what? Hearts and diamonds. There are 13 hearts. And 13 diamonds. Black has 13 clubs. And 13 spades. But also what we said way back at the beginning of like the total deck is there are 4 of each number. Right? So in the deck there are 4 of each number. And that's because there's a heart, a diamond, a club, and a spades of that number. A heart, a diamond, a clubs, and a spades of that queen. Right? A heart, a diamond, a club, and a spade of that king. Right? All of them have each suit. So, if you're asked, what is the probability that you will get a black card? How many black cards are there? How many total cards are there? So, this would be 26 out of 52. But what's another way that we could say that, especially when we look at the deck like this? Half of the deck, right? Half. Half the deck. Our chance is 1 out of 2. 1 out of every 2 cards. If I shuffle this up and draw, 1 out of every 2 cards is black. But if I think about the probability of a club, how many clubs were there? 13 out of how many total cards? 52. Or, guys, we can come over here and think how many suits, these are called suits again, how many suits were there? 4. Clubs is 1 out of 4. Right? Clubs is 1 out of the 4 suits. And now C, the last problem we need to talk about today. Notice, here when it says face card, it specifies King, Queen, Jack. And it's because aces don't have faces, right? These cards have faces on them. Aces do not have faces. They're powerful, but they a lot of times do not count as face cards. I know some of you play games at home and like you've got your own rules. So, check it. Here's how we do this. How many kings, queens, and jacks together are in the deck? If there are 4 of each of them. 4 and 4 and 4. 12. Please write this down. Trust me. Out of how many total cards? 52. Careful. But then this problem says we're going to do this 100 times. So we would actually take our probability and multiply by 100. So we grab our calculator to do this. 12, 52 times 100. So we would guess that we'll get approximately 23 face cards. This is our chance of getting a face card. And this is how many times we're going to try it. we can use a squiggly equals to say approximately 23 face cards out of 100. Right? We draw a card from the deck 100 times. And if you're super bored and want to try this, that should actually work. If you always put the card back in, always have a nice shuffle and a nice mix, that should work. Guys, this is not due tomorrow. We're slowing down. Okay? The earliest it would be due is Friday. Okay, the earliest I would ask for this is Friday. I kept you a little late. I'm sorry. I apologize to Goldring for me. I'll go take her a penance or whatever you call it, like or when you give somebody a gift to say I'm sorry. Yeah, an offering to apologize. Hey, you can also Google this. If you forget what's in a deck of cards, Google it. Amazing.
Power of Google.
Power of Google.